We want to talk about differentiation and integration. Well, we'll start with differentiation. But before that, calculus is subdivided into differentiation and integration. Calculus as a branch of math is the study of changes. And they say the only thing that is constant in life is change. So the study of change is calculus. Differentiation, for example, is subdivided into exponential and virtual values of differentiation. But we're going to consider the exponentials in this class as far as this unit is concerned. Now, let's start with the fact that if you write this value, y is equals to change, y is equals to x squared plus 2x. If I write this value, now dy over dx means change in y with respect to x is equal to 2x plus 2. This is the value of its own. And this is gotten from the fact that if y is equals to x raised to power n, dy over dx is equals to nxn minus 1. What it means is you take the value of n back, multiply, then xn raised to power minus 1. But what about a situation where y is equals to axn? But funny enough, the n is set, the a itself is a constant value. A constant is that value that you know. Now, but the x is a variable. So if you use the n to multiply that, you have now dy over dx gives me n times a becomes an x n minus 1. So what it means is that if I have y to be equals to 4x raised to power 3, dy over dx will give me 3 times 4, that's 12x, 3 minus 1. That becomes 12x squared. That's the value. Now, that's that. It's possible for me to have something like this. For example, I have y is equals to root of x. I can rewrite this as x 1 over 2. So dy over dx will give me half, multiplying 1 over 2 x, 1 over 2 minus 1. That will give me 1 over 2 x minus half. And that gives 1 over 2 times 1 over x half. And that gives 1 over 2x half. And that is the final value of 1 over 2 root x. So, this is what we call the general method of differentiation. But before then, we're going to consider another aspect of differentiation, which is called the first principle method. Now, the first principle method is simple. It's just coexpansive in the sense that if you have y to be equals to 2x squared plus x, for example, if you have to solve using first principle, all you need to do is you just write dy over dx is equal to 2x plus dx all squared plus x plus dx minus 2x squared plus x. If you watch what I did out here, you'll discover that Anywhere I find x, what I replace it with was x plus dx. I did the first thing here. I replaced x plus dx with x and I got squared. And this one I replaced with x plus dx. But after then, I now subtracted the value of y away. What's the value of y? 2x squared plus x. All divided now by that value dx. Now you continue by opening the bracket 2. That becomes x squared plus 2x dx plus dx squared. And that will give us the same value as plus x plus dx. And it becomes minus that becomes minus 2x squared plus x, all divided by dx. What I did was, first of all, I opened this bracket. When you open that bracket, expansion, you get x squared plus 2x dx plus dx squared plus, now this, if you open this, is something as x plus dx minus. I have to cover the bracket because of the sign minus. Now when you expand that further, 2 times this, that will be 2x squared plus 4x dx plus 2 dx all squared plus x plus dx minus 2x squared plus x all divided by dx. Let's start the cancelling now. If you look at it, this will cancel this at the same value, plus minus. Again, this will also cancel this, plus minus. This is minus this, minus this. So from here, after having these as the values, it's possible we have 4 dx, 2 dx squared plus dx. So we'll have our next value should be 4 x dx plus 2 dx squared plus the value dx, all divided by dx. Now, what is common between them is dx. If you bring that dx out, you have dx, you have 4x, you have plus 2 dx plus dx plus 1, all divided by dx. Because if you take dx out, if you open the bracket back, dx times this is this, dx this is the 2 dx squared dx. So these cancel this. So dy over dx, where we're starting from, as dx tends to 0, what it means is that after getting to this place, after dividing your dx, any value of dx that is left have to be equals to 0. So dy dx as dx tends to 0 is dy over dx equals to, if you place 0 here, that's the only value. So you have 4x plus 2 into bracket 0 plus 1. That becomes 4x plus 1. So if you differentiate that, that's 4x plus 1. So from here, anywhere you find the value of x, you replace it with x plus dx. That is how you solve questions that has to do with first principle. But funny enough, that's a wonderful one. But this same question, which is y is equals to 2x squared plus x. If you are using the differentiation method, you just have dy over dx will give you 2 times 2 in the front, that's 4, x 2 minus 1 plus x 1 minus 1. That becomes 4x plus x raised to power 0. That becomes 4x plus 1. And anything raised to power 0 is equals to 1. So you see it's shorter, but this is longer. But that's what they call the first principle. And this is called the differentiation rule. Now, we'll have to take more questions to allow differentiation sink. Now, let's consider this. let's consider what we call the function of a function. The function of a function is a rule used for differentiation. For example, if I have something like y is equals to u, I have y to be equals to u, and u is a function of x. That's why it's called a function of a function. It's a function of x. Then what it means is that dy over dx is equals to du over dx times dy over du. So you can see it's a very simple analogy. So you can see that this can cancel this. But let me see, I have an example. If you have y is equals to maybe 3x squared plus 1 all raised to power 3. You have to do that. So if you are solving such a question, you say let u be equals to 3x squared plus 1. So whatever is inside this bracket is 3x squared plus 1. So it can be represented with the value of u. So with that, u is this. So therefore, what is y? Y now is equals to u raised to power 3. So if you are having that, it's easier for us to say that du over dx from here, du over dx from here, du over dx will give us 6x plus 0. And here, dy over du will give us 3u raised to 2. So from there we have dy over dx is equals to, applying your formula, du over dx times dy over du. So let's multiply them together. You take du dx. Du dx is 6x times 3u squared. 6 times 3, that's 18x u squared. That's 18x. And finally, the u itself was represented with 3x squared plus 1 all squared. So that's the value. But that's simple enough. But you can shorten that calculation. The normal procedure, y is 3x squared plus 1 squared. Let u represent this. You find du dx, then you find dy du. You multiply them together, you replace the value of u, and you get your value. Now, but you can also apply a shorter method. You just do something like this. You just say y is equals to 3x squared plus 1 raised to power 3. What do? dy over dx. Take it. You take the power across. You have 3. You have 3x squared plus 1. Then 3 minus 1. Then you have it times. What that means is that you take the value of the power across. You have 3x squared plus 1, 3 minus 1. Then when you have the multiplication, what do you do after the multiplication? What you do is simple. Differentiate whatever is inside the bracket. What is inside the bracket is 3x squared plus 1. If you differentiate it, what you get is 6x. So when you multiply, then you have 3x squared plus 1 raised to power 2 times 6x. 6x is 3. That will give us 18x into bracket 3x squared plus 1 raised to power 2. It's shorter. Done. So that is function of a function. But there are sometimes you have something to do with function of a function and what we'll call exponential functions. But if you have a problem with this, if y is equals to log ex, if you have a statement like this, this is what we call the in Kappa's logarithm. The E is in Kappa's logarithm. The in, you have in Kappa's logarithm, we have the Neperian logarithm. So, which can also be in X. Now, from that value, dy over dx of this expression can be represented as something of this nature, as 1 over x. So, y is log x Neperian. The y dx of it is 1 over x. Now, I want to solve a question with respect to that. Let me take one from your module. Now, let's see this. Let's take this example. Y is equals to log 4x. Find the y dx of y equals to log 4x. Now, if you are having this, first of all, you use the function of a function. Let u be equals to 4x. Let u equals 4x. Therefore, y is equals to log u. So what it means, you can decide to put the e Kappas there or whatever, but du over dx will give me 4. dy over du will give me 1 over u. So therefore, my dy over dx from the function of a function is 4 times 1 over u. That becomes 4 over u. And that becomes 4 over, and the u itself, what was u representing? So u is equals to 4x. So what was u representing? So automatically it gives me u, and the u is 4x. So that will give me 4 here, 4, that becomes 1 over x. So normally the y over dx of y is equals to log u, the y over dx is 1 over u, and the u over dx gave me the value of 4. So what do you need to do? The y dx is times that, and you have your 1 over x. Good. It's easy. Now let's now see something else. Like if you have a value, like you want to consider values like y is equals to x plus 1, x minus 1, or probably 2. And this is the product rule. The product rule says that if y is equals to uv, it said the y over dx is equals to v du over dx plus u dv over dx, meaning differentiate, write one, differentiate the other, write one, differentiate the other, in that order. So from there, if I have a problem like this, so my dy over dx is simple. This is u and this is v. So what do? The v will be written first, x minus 2. And what is the y dx of x plus 1? That is 1. Plus, I will need to write the next one, which is v. U now, and when I write u, that's x plus 1. The y dx of v is also 1. So what I have now is x minus 2 plus x plus 1. If you take that out, you have 2x minus 2 plus 1. That's minus 1. So that's the value for the y dx. So always remember the product rule. Now, then we have the function of a function. Now after that, let's consider another rule that can be used for differentiation in both angles. Now, one of those rules is what we call quotient rule. The quotient rule. The quotient rule, you can call it the division rule. It's called the division rule. Now, if I have y to be equals to uv, u divided by v. So what it means is that dy over dx will give me v du over dx minus u dv over dx divided by v squared. So I can have this. So for quotient rule. Now, it's possible for you to say now that your first value, if you have y to be equals to 3x over x plus 4, this is u and this is v. So let's use this rule. So dy over dx is equal to v first, then we differentiate u. What's the v? We have x plus 4. Differentiate as dy dx of 3x is 3 minus. The next one is to write v and differentiate. Write u and differentiate v. So what is u? U is 3x. We differentiate that's 1 divided. What's the value down? The value down is v squared. So that's going to be x plus 4 squared. So if you take that out, you have 3 times x, that's 3x plus 12 minus 3x. Divided by x plus 4, as x plus 4 all squared. Finally, that gives me cancel, that is 12, and you have x plus 4 all squared. That is the value of dy dx for quotient rule. Now, it's easy to consider some of those basic facts. Like, for example, you are given values like this. Maybe you are told that y, you have to find the derivative of 6x raised to power 4 plus 3x squared minus 2x divided by x squared. So what you do for this is simple. It looks a little bit complex. So what you do is you try to simplify first of all. How do you simplify this? You divide all through 6x raised to power 4 divided by x squared plus 3x squared divided by x squared minus 2x divided by x squared. So if you have this, what you finally get here is 6x squared, this will cancel, plus 3 minus 2 over x. So if you're having something of this nature, it's easy to calculate now. Now, from here, it shows that y now is equals to 6x squared plus 3 minus 2x minus 1. The reason is because when the x is beneath denominator, if it comes up, it becomes minus 1. Because here, the x has a value of plus 1. Now, from here, let's see the dy dx. The y dx becomes 12x plus 0. The y dx of a constant is 0. The y dx of minus 100 is 0. The y dx of 2 million is 0. I'm a constant too. Probably the y dx of me is 0. So, now, minus this. That takes that forward. That becomes minus 1 times the 2. Times the 2. Then you have x minus 1 minus 1. That becomes 12x plus 0. Minus as plus. So that gives me plus 2. X raised to power minus 2. Finally, I'll have 12x plus 2 over x squared. So that's the value for the dy dx. It's simple. Remember, you get a complex value, you find every means to reduce it. So it's now reduced. So from being reduced, it's easy for you to calculate. Or you can just decide to use your UV principle, which is quotient rule. Now, that is that. Let's consider these guys from, what do you call it? I said that if y is equals to sine x, we're told that dy over dx is equals to cos x. So if y is equals to cos x, we're told that dy over dx is equals to minus sin x. So consider this. So automatically, if you are given a question like find dy over dx of values like maybe you are told that find dy dx of value like y is equals to sine 4x squared. You have to find such a value. It's simple. What do? Dy over dx. Let's use the shorter method. Just differentiate this thing. When you differentiate that, that is 8. When you differentiate that, that's 8. So that's 8x. That will be 8x times. What about dy dx of sine? Dy dx of sine is sine, is cos. So you write it back again, 4x squared. So your final answer is 8x cos 4x squared. So if I want to take values like this, I want to take value like this. Maybe I'm told that find dy dx of y is equals to 4 sine 3x plus 2 cos 6x squared. If I have something like this, simple, dy over dx, let's go. Dy dx of 3x is 3. Multiply with the 4 at the back, that will be 12. Dy dx of sine is cos 3x plus dy dx of 6x squared. Automatically, that will give you another value entirely, which is 12x. The 12x times the 2 at the back, surely that will become 24x. The ydx of course is minus sine. That's minus sine 6x squared now. So if you open the bracket, you have 12 cos 3x minus, because minus times plus is minus. So that's 24x sine 6x squared. So you have that. Oh, what about a case where the powers tend to be square and whatever? So in that case, it's easy for you to say, y is equals to sine, maybe you have sine square 5x. If you have something like this, there's a square now. So what you do is y is equal to, what it means is that y is equal to, let's first of all let u be equals to 5x. So y now is sine u all squared. That's what it means. It's the same thing. Sine square u is the same thing as sine u all squared. So if you have something of this nature, it's easy. So automatically, or it depends on if you want to write in a direct form. You can have y is sine 5x all squared. It's still the same thing. So you can now have u to be equals to sine 5x. So dy over dx. Okay. Y now is equals to u squared. So dy over du is equals to 2u. So du over dx is equals to 5 cos 5x. So what that means is that dy over dx, which is the complete value, becomes the multiplication of this and this. So when you multiply that, you have 2u times 5 cos 5x Okay, multiplying that together analytically gives me 2 times 5, that's 10. That gives me 10u cos 5x. But the u, what's the value of the u? The value of the u is sine 5x. So that gives me 10 sine 5x cos 5x. So that's the answer to that. Simple. But basically, this can be something else in trigonometry. But we're not discussing trig. So, if I decide to say, okay, y is equals to log 3x cubed. So I will let my u to be equals to 3x cubed. So because of that, my y will become log u. So dy over du is equals to 1 over u. Know that? So if that is 1 over u, and that takes me back to the fact that du over dx will now become 9x squared. So it's easy now. Therefore, dy over dx, which is the final value, is the multiplication of these two together. So when you multiply them, you have 1 over u times 9x squared. That becomes 9x squared over u. And remind us, what is u? 3x squared. So that's 9x squared over 3x cubed. So if that's that, so 3 here 1, 3 here is 3. X cubed, so that will give us 3 over x. So that's that. Now we've been able to analyze differentiation on both sides. The next thing we're going to talk about is the reverse of differentiation, which is integration. Now let's talk about integration, which is the converse or the reverse of differentiation. Now, integration is anti-differentiation. Good. For the integral rules, if you're giving values like, maybe I give you y is equals to 4x cubed, the y over dx of this will automatically be 12x squared. That's for the y dx of that. But I can reverse this value back to get the value of y. But for me to do that, I will need to apply the fact that if y is equals to xn, then the integral of xn is equals to xn plus 1 over n plus 1 plus a value called c. Now, let's continue. From here, if I want to reverse this value back, it's easy. All I need to do is the integral of 12x squared. I'm reversing it back to the value of y. So that will give me dx. That will give me 12x 2 plus 1 divided by 2 plus 1 plus c. That becomes 12x 3 over 3 plus c. 3 here, 3 here. That becomes 4x raised to power 3 plus c. So now, the reason why you have the constant is called the arbitrary constant. Or you just call it constant. And now you call it constant, you call it arbitrary constant. Now, the arbitrary constant is just there because when you differentiate a constant, it will be 0. So we don't know the actual constant that was differentiated, whether it's 100, 200, because all of them will be 0. So just to represent all the other constants, it was taken there as the arbitrary constant, which is the constant of, we call it the integral constant. Good. Now, that is integration. But integration itself has its own rules. One of the rules of integration is that if, for example, you are integrating a particular value, maybe you are asked to integrate 6x squared plus 4x dx. One of the rules of integration, which is the first rule, says that as far as it is a sum, maybe what it means is sum minus or plus, it can be separated in the sense that you can have integral of 6x squared dx for this plus integral of 4x dx. They are not separated, so you can have it. That's one of the rules. So from here, if I want to integrate this, I'll have 6x 2 plus 1 plus, I can have this 4x 1 plus 1. Where did the 1 come from? There's 1 here, divided by 1 plus 1 plus c. That gives me a value of 6x cubed over 3 plus 4x squared over 2 plus c. 3, 3, 2, 2. So automatically from there, it's easy for us to conclude now that this value here will be 2x cubed plus 2x squared plus c. That's it. Somebody is asking, can't you combine the two of them? No. X raised to power 3, x raised to power 2. So you can combine. So basically from there, we can have other values. That's one of the rules of integration. And another rule of integration is that if, for example, you are integrating a value, maybe 5x raised to power 3 dx, it says that you can bring out a constant value, which is 5, to become x3 dx. You can do that too, meaning you bring out a constant value. So if you're having something like you can have 5 maybe times, you have x3 plus 1, x3 plus 1 plus c. So that becomes 5. That will become 4 over x, 4 over 4. That's 3 plus 1. That becomes 4. So that becomes 5x4 divided by 4. So you can have that too. And one of the other rules, that's the second rule. The other rule is that sometimes when you differentiate when you take the integral of some values, you will observe that, for example, I have integral of 2 over 2x plus 1. Sorry, 1 plus 2x if dx. If I have something like this, you observe that if I have this, if I differentiate the denominator, what you get is the same value as the numerator. What I mean is, if you differentiate the value of 1 plus 2x, what you get is 2, the differentiation. So automatically, whenever you have a problem of this nature, that if the denominator is differentiated and it gives the same value as the numerator, then what you do, the integral automatically becomes the logarithm of the denominator. Log e 1 plus 2x. That's what we give. That's the direct value. Now, what about a situation where I'm giving something like this? I'm giving 3x squared divided by x cubed plus 1. If I have something of this nature, dx, if you differentiate this denominator, what it will give to you is 3x squared. So the direct answer becomes log e. The denominator is x cubed plus 1. So those are rules, basic rules of integration. And from there we can access other questions for integration. The value still remain y is x n plus 1 over n plus 1 plus c. Don't forget the arbitrary constant, which is the integral constant. Let's take a look at something of this nature. Maybe you are told, maybe you have something like maybe integrate 4 x squared plus 3x squared dx. If you have something of this nature, so the solution to that will be 4x 2 plus 1. That's for the first power, divided by 2 plus 1. That's 3x 2 plus 1 divided by 2 plus 1 plus c. That ends up becoming 4x raised to the power 3 over 3 plus 3x raised to the power 3 over 3 plus c. So you have this as your value. So integration basically is simple. All you need to do is follow the basic rules of integral constants. So we'll come to the end of this introduction to differentiation and integration. Thank you. I'm your maths instructor,